Hello, in this lecture we will find out the value of angle x using two different methods. In the drawing we have triangle PQR. We know that QS equals to SR. We also know that angle PSQ equals to 45 degrees, angle PQR equals to 3x, and angle PRS equals to x, and we want to find out the value of angle x. So we'll start with the first method. In the first method, we will define angle QPS as alpha and angle SPR, this angle is beta, and the value of this angle PSR, we define this y, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line QR, at point S, the sum of the angles must be equal to 180 degrees. That is to say, 45 degrees plus angle Y must be equal to 180 degrees. So here we will subtract 45 degrees from this equation, and we get that angle Y equals to 180 degrees minus 45 degrees. It equals to 135 degrees. So we found out that angle Y equals to 135 degrees. So we will substitute Y by 135 degrees. In the next step, I will present to you a new rule that is actually the law of sines. The law of sines is true in any triangle, so we can write down that in any triangle if we have this triangle and we know that the length of this side is A units, the length of this side of the triangle is B units, and the length of this side of the triangle is C units, and we also know that this is angle A, this is angle B, and this is angle C. Then according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Here I will repeat again. A over sine A equals to B over sine B equals to C over sine C, when A, small b, and small c are the lengths of the sides of the triangle, and capital A, capital B, and capital C are the sizes of the angles of triangle ABC. So from this equation, from this formula, we will derive that A over sine A equals to B over sine B and here we will multiply, we divide this equation by b, and then we will multiply it by sine a, and we will get that a over b equals to sine a over sine b. So actually, what is the meaning of this equation? The meaning of this equation is that the ratio of the side lengths in any triangle is equal to the ratio between the opposite angles. I repeat again, the meaning of the formula that a over b equals to sine a over sine b is that the ratio of the side lengths in any triangle is equal to the ratio between the opposite angles. Okay, so now we will return to our original drawing. In our original drawing, we can create the formula, the equation that states that PS over QS PS over QS equals to PS over SR. I repeat again. Question number 1 states that PS over QS equals to PS over SR. Why equation number 1 is true? Equation number 1 is true because of the fact that QS equals to SR. Here it is given us the equation that QS equals to SR. QS equals to SR. But according to the equation that A over B equals to sine A over sine B, actually PS over QS, if we relate to triangle PQS, PS over QS will be equal to sine 3x over sine alpha. Likewise, PS over SR, if you relate to triangle PSR, will be equal to sine X over sine beta. Okay? We know that the sum of the angles in any triangle is equal to 180 degrees. So if we relate to triangle PQS, in triangle PQS, the sum of the angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. I will repeat again, in triangle QPS, the sum of the angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. Here we will subtract 3x and also 45 degrees from this equation, equation number 2, and we will get that according to equation number 2, alpha equals to 180 degrees minus 3x plus 45 degrees. Okay, so we found out the value of alpha in terms of x, and likewise in triangle PSR, the sum of the angles is equal to 180 degrees. That is to say, if we focus on triangle PSR, we will get that beta plus 135 degrees plus angle x must be equal to 180 degrees. Again, in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus 135 degrees plus x equals to 180 degrees. Here we will subtract 135 degrees and also x from equation number 3, and we will get that according to equation number 3, beta equals to 180 degrees minus 135 degrees is 45 degrees minus x. Okay, so we found out the value of beta in terms of x, and we also know what is the value of alpha. Now we can substitute alpha and beta in this equation number 1, by the values that we found out in the equation number 2 and the equation number 3. So we will do it now, and we will get that according to equation number 1, sinus 3x over sinus alpha, and alpha equals to, according to equation number 2, it equals to 180 degrees minus 3x plus 45 degrees, and it equals to sinus x over sinus beta, and beta equals to 45 degrees minus x according to equation number 3. Okay, but we have the trigonometric identity that states that sinus 180 degrees minus theta equals to sinus theta. So according to this trigonometric identity, we will get that the value of sinus 180 degrees minus 3x plus 45 degrees will be equal to sinus 3x plus 45 degrees. So we'll change the sinus 180 degrees minus 3x plus 45 degrees in equation number 1 by sinus 3x plus 45 degrees. So we'll do it now, and we will get that according to equation number 1, sinus 3x over sinus 3x plus 45 degrees equals to sinus x over sinus 45 degrees plus x So here we will cross multiply equation number 1, and we will get that sinus 3x plus sinus 45 degrees plus x equals to sinus x times sinus 3x plus 45 degrees So here we will multiply equation number 1 by 2 and we will get that 2 sine 3x sine 45 degrees plus x equals to 2 sine x sine 3x plus 45 degrees. So here we will use the trigonometric identity that states that 2 sine A sine B equals to cosine A minus B minus cosine A plus B. We will use this trigonometric identity in order to simplify our equation number 1. So here in our expression 2 sine 3x sine 45 degrees plus x, A equals to 3x and B equals to 45 degrees plus x. So according to this trigonometric identity, 2 sine A sine B equals to cosine A minus B minus cosine A plus B, we will get that 2 sine 3x sine 45 degrees plus x equals to cosine A minus B. A is 3x and B is 45 degrees plus x, so A minus B will be equal to 3x plus 3x minus x is 2x and 0 minus 45 degrees is minus 45 degrees. And we have also to subtract cosinus A plus B. A plus B is 3x plus x is 4x. And 0 plus 45 degrees is 45 degrees. So we finished with this expression. Now we will treat the other expression on the other side of the equation number 1. Here we have 2 sine x sine 3x plus 45 degrees. So here A is equal to x and B is equal to 3x plus 45 degrees. So 2 sine A sine B equals to cosine A minus B. A is x, B is 3x plus 45 degrees. So x minus 3x is minus 2x and it is also 0 minus 45 degrees is minus 45 degrees. So we got cosine minus 2x plus 45 degrees, but because of the fact that cosine minus x equals to cosine x, we can change the negative sign in cosine minus 2x plus 45 degrees to positive sign. So in conclusion, we got that the first expression is cosine 2x plus 45 degrees, and we also have to subtract cosine a plus b. A is x, b is 3x plus 45 degrees, so x plus 3x is 4x, and 0 plus 45 degrees is 45 degrees. So here we have cosine 2x minus 45 degrees, so I will copy it here. We have, according to equation number 1, cosine 2x minus 45 degrees and here we have minus cosine 4x plus 45 degrees so it is actually okay. So I will do it again here. We have 2 sine 3x sine 45 degrees plus x equals to 2 sine x sine 3x plus 45 degrees. So here a is 3x and b is 45 degrees plus x, and cosine a minus b is 3x minus x is 2x, and zero minus 45 degrees is minus 45 degrees, and we also have to subtract a plus b. So it is a is 3x, b is x, so 3x plus x is 4x, and 0 plus 45 degrees is 45 degrees. And in the other side of equation number 1, we have the expression 2 sine 2x sine 3x plus 45 degrees. So here a equals to x and b equals to 3x plus 45 degrees. So cosine a minus b is x minus 3x is minus 2x, and 0 minus 45 degrees is minus 45 degrees. So we got cosine minus 2x plus 45 degrees, and because of the fact that cosine minus x equals to cosine x, the negative sign will turn to the positive sign, so it is cosine 2x plus 45 degrees. And then we have also to subtract minus cosine a plus b. A is x and b is 3x plus 45 degrees, so x plus 3x is 4x, and 0 plus 45 degrees is 45 degrees. Okay, so let's see, there is a mistake here. Sinus 3x or sinus and then 3x plus 45 degrees equals to sinus x over sinus 45 degrees. Sinus 45 degrees minus 6. So instead of plus, instead of minus, I wrote plus, so it is the mistake. Then I have to cross multiply it here. So here it is minus, and it is minus. So here we have A is 3x and B is 45 degrees minus x, so it is A minus B is 3x minus x, 3x minus x is 4x, and 0 minus 45 degrees is 45 degrees, and we have also to subtract cosine A plus B, so it is A plus B is 3x plus minus x is 2x, and 0 minus 45 degrees is minus 45 degrees. And here we have the other side of equation number 1. A is x, B is 3x plus 45 degrees, so cosine A minus B is, here is cosine 2x plus 45 degrees, and we also must to subtract cosine A plus B. So here x plus 3x is 4x, and okay. So now I correct the mistake. So what we have here, we have cosine 4x minus 45 degrees we will add to this equation number 1, cosine 4x plus 45 degrees, and cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees equals to 2 times cosine 2x plus 45 degrees So we got this expression. Actually, cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees is very similar to the trigonometric identity that states that cosine C plus cosine D is equal to 2 cosine C plus D over 2 times cosine C minus D over 2 and the expression 2 cosine 2x plus 45 degrees is very similar to the trigonometric identity that says that cosine A plus B equals to cosine A cosine B minus sine A sine B So cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, C equals to 4x minus 45 degrees and d equals to 4x plus 45 degrees. So cosine c plus cosine d is 2 cosine c plus d over 2. C plus d, c is 4x minus 45 degrees, and d is 4x plus 45 degrees. So c plus d over 2 is 4x plus 4x, that is 8x. 8x over 2 is 4x, so it is cosine 4x times so it is actually 2 times cosine c plus d over 2 times cosine c minus d over 2. 4x minus 4x is 0, and here minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. But cosine minus 45 degrees equals to 45 degrees according to the trigonometric identity that cosine minus x equals to cosine x. Okay, so we finished if this side of equation number 1. Now we will treat this expression 2 cosine 2x plus 45 degrees. Here we use the trigonometric identity that cosine a plus b equals to cosine a cosine b minus sine a sine b. So here a equals to 2x and b equals to 45 degrees. So cosine a plus b is cosine a cosine b. That is to say a is 2x, so it is cosine 2x, and b is 45 degrees, so it is cosine 45 degrees minus sine 2x sine 45 degrees. Okay, so here we will divide equation number 1 by 2 cosine 45 degrees. So here 2 cosine 45 degrees will get cancelled. Here also 2 cosine 45 degrees will get cancelled, and here 2 sine 45 degrees will get cancelled because of the fact that cosine 45 degrees is equal to sine 45 degrees. So in conclusion, we got that according to equation number 1, cosine 4x equals to cosine 2x minus sine 2x. So here we will add to this equation number 1 sine 2x, and then we will subtract cosine 4x, and we will get that according to equation number 1 sine 2x equals to cosine 2x minus cosine 4x. We know that sine 2x equals to 2 sine x cosine x. And actually cosine 2x minus cosine 4x is very similar to the trigonometric identity that states that cosine c minus cosine d equals to 2 sine d plus c over 2 times c sine d minus c over 2. Again, cosine c minus cosine d equals to 2 sine d plus c over 2 times sine d minus c over 2. So here a equals to 2x and b equals to 4x, and it is actually c equals to 2x and d equals to 4x. So cosine c minus cosine d is equals to 2 sine d plus c over 2. That is to say, it equals to 2 sine d plus c. D is 4x, c is 2x, so 4x plus 2x is 6x, and 6x over 2 is 3x. So in conclusion, we got 2 sine 3x, and we also must multiply it by sine d minus c over 2, so it is sine d minus c is 4x minus 2x, so 4x minus 2x is 2x, and 2x over 2 is x. So in conclusion, we got that 2 sine x cosine x equals to 2 sine 3x sine x. We will divide equation number 1 by 2 sine x. So here 2 sine x will get cancelled, and here also 2 sine x will get cancelled. What is left from equation number 1 after we divide it by 2 sine x? What is left is actually cosine x equals to sine 3x. Okay? We got that according to equation number 1, cosine x equals to sine 3x. But we have the trigonometric identity that cosine x equals to sine 90 degrees minus x. So we can substitute cosine x in equation number 1 by sine 90 degrees minus x. So we get that sine 90 degrees minus x equals to sine 3x. Sine 90 degrees minus x equals to sine 3x means that 90 degrees minus x equals to x, and 90 degrees minus x equals to 3x. Here we will add to equation number 1 x, and we will get that 90 degrees equals to 3x plus x, that is 4x. We will divide equation number 1 by 4, and we will get that x equals to 90 degrees over 4. 90 degrees over 4 is 22.5 degrees. So we found out that x equals to 22.5 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of angle x according to the second method. In the second method, we will define this angle as alpha, this angle as beta, as we did in the first method. We have already found out that this angle equals to 135 degrees, and we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle PQS, this triangle, the sum of the angles must be equal to 180 degrees. That is to say alpha plus 3x plus this angle that is 45 degrees must be equal to 180 degrees. I repeat again, the sum of the angles in triangle PQS must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. We will subtract 45 degrees from this equation number 1, and we will get that alpha plus 3x equals to 180 degrees minus 45 degrees is 135 degrees. So we found out that according to equation number 1, alpha plus 3x equals to 135 degrees. Likewise, in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus x plus 135 degrees must be equal to 180 degrees. I will repeat again. In triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus x plus 135 degrees equals to 180 degrees. We will subtract 135 degrees from this equation number 2, and we will get that according to equation number 2, beta plus x equals to 180 degrees minus 135 degrees is 45 degrees. Here we will multiply equation number 2 by 3, and we will get that 3 beta plus 3x equals to 45 degrees times 3 is 135 degrees. So here we can create equation number 3 that states that equation number 1 equals to equation number 3, because in both sides, in both equations, we have 135 degrees. So equation number 1, that is actually alpha plus 3x, equals to equation number 3, that is actually 3 beta plus 3x. Here we will subtract 3x from this equation number 3, and we will get that alpha equals to 3 beta according to equation number 3. Alpha equals to 3 beta. Okay. In the next step, we will do a construction. From point Q, we will draw a straight line to PR in such a way that the angle that will be created here will be equal to x. Okay? Again, we draw the straight line from point Q to PR in such a way that this angle will be equal to x. But we know that angle QPR equals to 3x, and this angle equals to x, so the rest must be equal to 3x minus x. That is to say 2x. 3x minus x is 2x, so actually angle PQ here equals to 2x, this angle equals to 2x. We will define the touching point between the straight line from point Q to PR as point M. Because of the fact that triangle QMR has 2 equal angles, it means the triangle QMR is an isosceles triangle. And the base of the isosceles triangle QMR is QR. Okay? we will join points M and S together by a straight line. MS is the median to the base of the isosceles triangle QMR, and according to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. That is to say, the median AMS is perpendicular to the base QR. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule number 3. Okay, in the next step, I will present to you a new rule, rule number 4. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles, to the sum of the two angles that are not adjacent to it. I will read rule number 4 again. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC, so this is triangle ABC. Alpha, beta, and gamma are defined as the interior angles of triangle ABC because they are located inside the triangle, and this angle ASAB is defined as an exterior angle of triangle ABC. Why ASAB is an exterior angle? Because it is located outside the triangle. So angle ASAB, this angle is defined as an exterior angle of triangle ABC. And according to rule number 4, an exterior angle of a triangle, that is to say angle SAB, is equal to the sum of the two angles that are not adjacent to it. The exterior angle SAB, this angle, is equal to the sum of the two angles that are not adjacent to it. So which angles are not adjacent to this angle? Angle gamma is adjacent to angle SAB, as you can see. And the only two angles that are not adjacent to this angle are those two angles, alpha and beta. And the sum of those two angles is actually alpha plus beta, and according to Rule number 4, the value of the exterior angle SAB equals to alpha plus beta. That is the sum of the two angles that are not adjacent to it. The sum of the two angles that are not adjacent to it is alpha plus beta, so the value of angle SAB, the exterior angle SAB, is equal to alpha plus beta. We can implement rule number 4 in our drawing. And if we have triangle QMR that is an isosceles triangle, the interior angles of triangle QMR are those two angles, and this angle are defined as the interior angles, while angle PMQ, this angle, is defined as an exterior angle of triangle QMR. And according to rule number 4, the value of the exterior angle of triangle QMR is equal to the sum of the angles that are not adjacent to it. This angle is adjacent to it. It is adjacent to angle APMQ. And the only two angles that are not adjacent to angle PMQ are those two angles. And the sum of those two angles is x plus x. That is to say, the exterior angle PMQ equals to 2x. According to rule number 4, here we have triangle PMQ. This triangle is an isosceles triangle that, because of the fact that it has two angles that are equal to each other, both those two angles are equal to 2x. And according to the rule that in front of equal angles in a triangle there are equal sides. So in front of those two equal angles there are equal sides. Those two sides are located in front of the equal angles, therefore they are also equal to each other. That is to say, PQ is equal to PM. We found out that PQ equals to PM. In the next step, we will draw perpendicular from point P to QM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. And then we will extend the perpendicular until it touches QS at point N. We will define the touching point between the perpendicular from point P to QM as point L. We will focus on those two triangles, triangle PQL and triangle PLM. Triangle PQL and triangle PLM. Those two triangles. In those two angles are equal to each other. They are both equal to 2x. So angle PQL in triangle PQL is equal to angle PLM is equal to angle PML in triangle PLM, and both angles are equal to 2x. Okay, angle PQL equals to angle PML, and both angles are equal to 2x. Those two angles are also equal to each other. They are both equal to 90 degrees. So angle PLQ of triangle PLQ is equal to angle PLM, this angle of triangle PML, and both angles are equal to 90 degrees. So actually angle PLQ equals to angle PLM, and both angles are equal to 90 degrees. And the third pair of angles, that is to say those two angles, or angle QPN is equal to angle LPM in the other triangle, this angle LPM, and those two angles are equal to each other according to third angle theorem. I repeat again, angle QPN equals to angle LPM according to third angle theorem. So, what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Why? Because the third pair of angles is complementary to 180 degrees. And what is the value of the third pair of angles? The value of the third pair, each one is equal to 180 degrees minus the sum of the two other angles. But the two other angles are equal in both triangles. Therefore, the third pair of angles are equal to each other. Okay? And we actually found out that those two angles in triangle PLQ are equal to those two angles in triangle PLM. That is to say, we found that in those two triangles there are two pairs of angles that are equal to each other. Therefore, the third pair of angles that is complementary to 180 degrees must be also equal to each other. That is to say, angle QPL equals to angle LPM. Okay? So those two angles are equal to each other. So if we define this angle as theta, then this angle must be also equal to theta because of the fact that those two angles are equal to each other. And as you can see clearly from the drawing, theta plus theta is actually this angle. Theta plus theta equals to alpha plus beta. This is actually also this angle QPR. Theta plus theta equals to angle QPR, and alpha plus beta also equals to angle QPR. Therefore, they are equal to each other. So we can write down that theta plus theta equals to alpha plus beta. From the drawing, you can see it clearly. Theta plus theta equals to alpha plus beta. Theta plus theta is 2 theta, and it equals to alpha plus beta. According to equation number 3, we have already found out that alpha equals to 3 beta. So we can substitute alpha in this equation by 3 beta. We will do it now, and we will get that 2 theta equals to alpha is 3 beta plus beta. 3 beta plus 3 beta is 4 beta. So we found out that 2 theta equals to 4 beta. We will divide this equation by 2, and we get that theta equals to 2 beta. So we found out that theta equals to 2 beta. Theta equals to 2 beta, so we can write here that theta equals to 2 beta, and also here we can write down that theta equals to 2 beta. You can see from the drawing that angle theta minus angle beta, this angle, equals to angle NPS. Again, if you subtract from angle theta in the red line this angle beta, you will get angle NPS. So angle NPS equals to theta, that is 2 beta, minus beta. 2 beta minus beta is beta. So we actually found out that angle NPS equals to beta. And likewise here, angle MSN is a right angle, it equals to 90 degrees. So if you subtract from the right angle, angle PSN, this angle, you will get angle PSM. Again, the right angle minus the angle that equals to 45 degrees will get angle PSM. So angle PSM equals to 90 degrees minus 45 degrees, that is actually 45 degrees. Okay? It is very simple to see that the right angle minus this angle equals to angle MSB, that is to say 90 degrees minus 45 degrees equals to 45 degrees, that is to say angle MSB equals to 45 degrees. In the next step, we will prove that triangle NPS is congruent to triangle SPM. So I will draw again the two triangles and we will prove that they can go into each other. So triangle NSP is congruent to triangle PMS. I'll repeat again. Here it is actually PM. Yes, this is N. So we will prove that triangle PNS, the green triangle, is congruent to the white triangle, triangle PSM. So I write it down. We will prove that the green triangle, triangle PSN, is congruent to the white triangle, triangle PSM. So why they congruent to each other? First of all, those two angles are equal to each other, they are both equal to beta. So angle NPS in the green triangle equals to angle SPM in the white triangle. And both those two angles are equal to beta. We also have a common side, PS is a common side. It belongs to both triangles, so we can write down that PS equals to itself. It's a common side that belongs to both triangles. And those two angles are also equal to each other, they are both equal to 45 degrees. So angle NSP of the green triangle equals to angle MSP of the white triangle, and both angles are equal to 45 degrees. So we actually proved that the green triangle, triangle PNS, congruent, this is the sign of congruent, to triangle, the white triangle, triangle PSM. And they congruent to each other according to side angle rule. I'll repeat again. The green triangle, triangle PNS congruent to the white triangle, triangle PSM according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles and the side that included between them in one triangle congruent to two angles and the side that included in another triangle, then you prove that those two triangles congruent to each other according to angle side angle rule. And we actually proved that those two angles and the side that included between them, that is to say PS, in the green triangle congruent to those two angles and the side that included between them, that is to say PS, in the white triangle. Therefore, we proved that those two triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that NS equals to SM. NS equals to SM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say NS and SM, must be also equal to each other. Okay, so in the next step I will connect together points M, N and M by a straight line, and I will draw triangle NMS in a new page. You can see that this angle is a right angle, and we also know that NS equals to SM. Okay, so we can write here that NS equals to SM, and I will draw triangle NMS in a new page. So this is triangle NMS. We know that NS equals to MS, and this angle is a right angle. We know that the sum of the angles in any triangle equals to 180 degrees. So if this angle is 90 degrees, then the two other angles must be equal to 90 degrees in order to complete the sum of the three angles to 180 degrees. So the sum of those two angles is 90 degrees, but according to the rule that in front of equal sides in the triangle there are equal angles, we have those two sides that are equal to each other, and in front of them there are equal angles. That is to say, those two angles are equal to each other. Those two angles are equal to each other. If we define angle SMN as y, then angle S and M will be also equal to y because of the fact that those two angles are equal to each other. And we also know that y plus y must be equal to 90 degrees in order to complete the sum of the angles in triangle NSM to 180 degrees. Y plus y is 2y, 2y equals to 90 degrees. We will divide this equation by 2 and we will get that y equals to 45 degrees. So we found out that angle y equals to 45 degrees. So here we'll substitute y by 45 degrees. Here y equals to 45 degrees. And here also y equals to 45 degrees. So we will join points N and M together by a straight line. We found out that angle MNS equals to 45 degrees. And also this angle equals to 45 degrees. Okay. In the next step, we will prove that triangle QPN or triangle PQN can go to triangle PNM. So I will draw those two triangles together and we will prove that they can go into each other. So triangle PQN can go to triangle PNM. So we will prove that the green triangle PQN can go to the white triangle PNM. So I write it down, the green triangle PQN can go to the white triangle PNM. Why they can go to each other? First of all, we have already found out that PQ equals to PM. Here PQ equals to PM, PQ equals to PM. Those two angles they are equal to each other, they are both equal to beta. So angle QPN in the green triangle is equal to angle NPM in the white triangle, and both angles are equal to 2 beta. PN is a common side, it belongs to both triangles. So we can write down that PN equals to itself. It's a common side that belongs to both triangles. So we actually proved that the green triangle PQN can go to the white triangle PNM according to side angle side rule. I will repeat again. We proved that the green triangle, triangle PQN, can go into the white triangle, triangle PNM, according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove the two angles, if you prove the two sides and the angle between those two sides in one triangle can went correspondingly to two sides and the angle between those two sides in another triangle, then you proved that those two sides, those two triangles can go into each other according to side angle side rule. And we actually proved that those two sides, that is to say PQ and PN, and the angle between them, that is to say 2 beta in the green triangle, can go into those two sides, that is to say PN and PM, and the angle between them, that is to say 2 beta in the white triangle. Therefore we prove that those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that Qn equals to Mn. Qn equals to Nm, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say Qn and Nm, will be equal to each other. So we can write here that Qn equals to Nm. In the next step, we will join points Q and M together by a straight line, and I will draw triangle Q and M in a new page. Here, angle MQN, angle MQN equals to X. So I will draw triangle QMN in a new page. So this is triangle Q and M. We know that Qn equals to Nm, Qn equals to Nm, and we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, in front of those two equal sides in triangle QMN there are equal angles. Those two angles are located in front the equal sides, therefore they are equal to each other. So those two angles are equal to each other. But this angle equals to x, so this angle must be also equal to x, also because of the fact that those two angles are equal to each other. Okay? This is point S. So, according to rule number 4, the exterior angle MNS of triangle QMN is equal to the sum of the angles that are not adjacent to this angle. And the only two angles that are not adjacent to this angle are those two angles, and the sum of those two angles is x plus x, that is to say 2x, and the value of the exterior angle MNS equals to the sum of the two angles that are not adjacent to it, that is to say it equals to x plus x, that is to say it equals to 2x. So we found out that angle MNS from one side it equals to 2x according to rule number 4. But from the other side, we have already found out that angle MNS, this angle equals to 45 degrees. On the other side, angle MNS equals to 45 degrees. And from this equation, we will conclude that 45 degrees equals to 2x. We'll divide this equation by 2 and we will get that x equals to 45 degrees over 2, that is to say 45 degrees over 2 is 22.5 degrees. So we found out that the value of angle x according to the second method is equal to 22.5 degrees. We finished with the first method. In the next step, I will summarize the lecture. Okay, so actually we wanted to find out the value of angle x, and we found out the value of angle x in two different methods. In the first method, we define this angle as alpha, this angle as beta, and this angle that is unknown, we define it as y, and we know that the sum of the angles on one side of the straight line is equal to 180 degrees, that is to say 45 degrees plus y must be equal to 180 degrees because QR is a straight line. Okay, so on the straight line QR, on the upper side of the straight line QR at point S, the sum of the angle must be equal to 180 degrees, that is to say 45 degrees plus the size of angle Y must be equal to 180 degrees. We subtracted 45 degrees from this equation and we got that angle Y equals to 180 degrees minus 45 degrees is 135 degrees. So we found out that this angle equals to 135 degrees. And we also know in the next step I presented to you the law of sines that is true in any triangle. If we have this triangle and we know that the length of this side is A units, the length of this side of the triangle is B units, and the length of this side is C units. This is angle A, this is angle B, and this is angle C. Then A over sinus A equals to B over sinus B equals to C over sinus C. This is the law of sines that is true in any triangle. Here we can derive from this formula that A over sine A equals to B over sine B. If we divide this equation by B and we will multiply it by sine A, we will get that A over B equals to sine A over sine B. What is the meaning of this equation? The meaning of this equation is that the ratio of the side lengths in any triangle is equal to the ratio between the opposite angles. Okay, again, the ratio of the side lengths in any triangle is equal to the ratio between the opposite angles. Okay, then in our drawing we can create equation number 1 that states that PS over QS equals to PS over SR. According to equation number 1, PS over QS equals to PS over SR, and why it is true? Because of the fact that QS equals to SR. But according to the equation that A over B equals to sine A over sine B, that is true in any triangle, PS over QS, if we relate to triangle QPS, PS over QS will be equal to sine 3x over sine alpha. PS over QS equals to sine 3x over sine alpha. And if we focus on triangle PSR, then PS over SR will be equal to sine x over sine beta. PS over SR equals to sine x over sine beta. And we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, in triangle PQS, alpha plus 3x plus 45 degrees equals to 180 degrees. Here we subtracted 45 degrees and also 3x from this equation number 2, and we got that angle alpha equals to 180 degrees minus 3x plus 45 degrees. Then, likewise in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus 145 degrees plus x must be equal to 180 degrees. We subtracted 135 degrees and also x from this equation number 3, and we got that beta equals to 45 degrees minus x. So we can substitute now alpha and beta in this equation number 1 by the values that we found for alpha and beta in equation number 2 and equation number 3. We did it, and we got that sine 3x equals to sine alpha. Alpha is 180 degrees minus 3x plus 45 degrees over sine x. It equals to sine x over sine beta, and beta is 45 degrees minus x according to equation number 3. Here we have the trigonometric identity that sine 180 degrees minus theta equals to sine theta. According to this trigonometric identity, we will get that sine 180 degrees minus 3x plus 45 degrees equals to sine 3x plus 45 degrees. So we can change this expression by sine 3x plus 45 degrees. We did it, and we got that sine 3x over sine 3x plus 45 degrees equals to sine x over sine 45 degrees minus x. Then we cross multiplied the equation number 1, this equation, and we got this expression. Then we multiplied this expression by 2, and we got this expression. Actually, we have the trigonometric identity that sine 2 sine A sine B equals to cosine A minus B minus cosine A plus B, and we can use this trigonometric identity in order to simplify those expressions. In this expression, A equals to 3x, B equals to 45 degrees minus x. Therefore, according to the trigonometric identity, 2 sine A sine B equals to cosine A minus B minus cosine A plus B. So cosine A minus B, cosine A is 3x and B is 45 degrees minus x, so A minus B is 3x minus x, that is actually 4x, minus is plus, and we also have 0 minus 45 degrees is minus 45 degrees. Then we also have to subtract minus cosine A minus B, so minus cosine A plus, it is actually minus cosine A plus B. So minus cosine A plus B, A is 3x and B is minus x, so it is minus cosine A is 3x, so it is 3x minus x, that is 2x, and we also have 0 plus 45 degrees is 45 degrees. So we got here cosine 2x minus 45 degrees. So we finished with this expression. Then we treated the expression in the other side of equation number 1, this expression. Here a equals to x and b equals to 3x plus 45 degrees. So we will get that 2 sine a sine b equals to cosine a minus b. A is x and b is 3x plus 45 degrees, so x minus 3x is minus 2x, and x and 0 minus 45 degrees is minus 45 degrees. So we got here that it equals to cosine minus 2x plus 45 degrees. But because of the trigonometric identity that cosine minus x equals to 2 cosine x, we can change the negative sign to a positive sign. We change it and we got here cosine 2x plus 45 degrees. Then we also have to subtract cosine a plus b. So it is minus cosine a plus b. A is x and b is 3x plus 45 degrees. So x plus x is 4x. And 0 plus 45 degrees is 45 degrees. So here we have cosine 4x minus 45 degrees. So I copied it here, cosine 4x minus 45 degrees. And here we have minus cosine cosine 2x minus 45 degrees. So we actually added, we have here cosine 2x, it is actually here cosine 4x. Okay, it is here cosine 4x. I correct it to cosine 4x. So we have cosine 4x, cosine 4x minus cosine 4x plus 45 degrees. So we added cosine 4x minus 45 degrees. It is actually cosine. Here we have minus cosine 4x plus 45 degrees, so we added to this equation cosine 4x plus 45 degrees. Okay, we have cosine 4x plus 45 degrees, and here we have cosine 2x plus 45 degrees, and here also it is cosine 2x plus 45 degrees, so it is 2 times cosine 4x plus 45 degrees. And here, this expression cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees is very similar to the trigonometric identity that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2. And the expression 2 cosine 2x plus 45 degrees is very similar to the expression that cosine a plus b equals to cosine a cosine b minus sine a times sine b. Okay, and here we have cosine 4x minus 45 degrees, c equals to 4x minus 45 degrees, and we have cosine 4x plus 45 degrees, so d equals to 4x plus 45 degrees, and cosine c plus cosine d equals to 2 cosine c plus d over 2. C is 4x minus 45 degrees and d is 4x plus 45 degrees. So 4x plus 4x is 8x and 8x over 2 is 4x. So we have here 2 cosine 4x. And we also have to multiply it by cosine c minus d over 2. C minus d is 4x minus 4x, that is 0. And we have minus 45 degrees, minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees, but because of the fact that cosine minus x is equal to cosine x, we can substitute cosine minus 45 degrees by cosine 45 degrees. We did it here. And we also treated this expression according to the trigonometric identity that cosine a plus b equals to cosine a cosine b minus sine a sine b. Here a equals to 2x and b equals to 45 degrees. So cosine a plus b equals to cosine a cosine b. So it is actually cosine 2x cosine 45 degrees minus 2 sine 2x, that is a, times sine 45 degrees, that is b. Here we divided this equation number 1 by 2 cosine 45 degrees, and we left with only cosine 4x equals to cosine 2x minus sine 2x. Here we added to this equation number 1 sine 2x, and then we subtracted cosine 4x. So we got here we got that sine 2x equals to cosine 2x minus cosine 4x, and cosine 2x minus cosine 4x is very similar to the trigonometric identity that cosine c minus cosine d equals to 2 sine d plus c over 2 times sine d minus c over 2. Okay, and according to this trigonometric identity we will get that it equals to 2 sine d plus c over 2, 4x plus 2x over 2 is 3x, times sine d minus c over 2. D minus c over 2 is 4x minus 2x over 2. That is to say, it equals to sine of x. So, in conclusion, we got 2 sine 3x times sine x equals to 2 sine x cosine x. Here we divided the equation number 1 by 2 sine x, and we left with the expression that cosine x equals to sine 3x. We have the trigonometric identity that cosine x equals to sine 90 degrees minus x, so we can substitute cosine x by sine 90 degrees minus x. So we did it, and we got that sine 90 degrees minus x equals to sine 3x. On this equation, we can derive that 90 degrees minus x equals to 3x. We added x to equation number 1, and we got that 90 degrees equals to 4x. We divided the equation number 1 by 4, and we got that x equals to 90 degrees over 4. 90 degrees over 4 is 22.5 degrees. So I found out that the value of angle x is equal to 22.5 degrees. We finished with the first method. Then I presented to you how to find out the value of angle x according to a second method. In the second method, we define this angle as A, this angle as B, as we did in the first method. And we have already found out in the first method that this angle equals to 135 degrees. And we know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle QPS, we will get that in triangle PQS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. We subtracted 45 degrees from this equation number 1, and we got that alpha plus 3x equals to 135 degrees. According to equation number 1, alpha plus 3x equals to 135 degrees. Then we focus on triangle PSR. We know that the sum of the angles on triangle PSR must be equal to 180 degrees. That is to say, beta plus x plus 135 degrees must be equal to 180 degrees. We subtracted 135 degrees from this equation number 2, and we got that beta plus x equals to 45 degrees. We multiplied the equation number 2 by 3, and we got that 3 beta plus 3x equals to 135 degrees. So we have 135 degrees in both equations. So we can compare equation number 1 to equation number 2. So we created equation number 3 that states that equation number 1 equals to equation number 2. That is to say, alpha plus 3x equals to 3 beta plus 3x. We subtracted 3x from this equation number 3, and we got that alpha equals to 3 beta. So according to equation number 3, alpha equals to 3 beta. Then I did a construction from point Q. We drew a straight line to PR in such a way that angle MQR, this angle will be equal to x. So because of the fact that this angle equals to x and this angle also equal to x, it means the triangle QMR is an isosceles triangle because it has two angles that are equal to each other. And the base of triangle QMR is QR. We join points M and S together by a straight line. MS is the median to the base, and according to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base, so the median MS is perpendicular to the base QR. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then I presented to you rule number 4. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC, triangle ABC has two interior angles. Angles alpha, beta, and gamma are defined as the interior angles because they are located inside the triangle, while angle SAB is defined as an exterior angle because of the fact that it is located outside the triangle ABC. And according to rule number 4, the value of the exterior angle SAB is equal to the sum of the two angles that are not adjacent to it. Angle gamma is adjacent to angle SAB, and the only two angles that are not adjacent to it are those two angles, and the sum of those two angles is alpha plus beta. So according to rule number 4, the value of angle SAB, the exterior angle SAB, is equal to alpha plus beta because of the fact that the value of the exterior angles is equal to the sum of the angles that are not adjacent to it. Angles alpha and beta are not adjacent to it, and the sum of angles alpha and beta is alpha plus beta. Therefore, the value of the exterior angle SAB is equal to alpha plus beta. We can implement rule number 4 in our drawing, because in our drawing we have triangle QMR. The exterior angle of triangle QMR is PMQ, and according to rule number 4, the value of this exterior angle is equal to the sum of the angles that are not adjacent to it, and the two angles that are not adjacent to it are those two angles, and the sum of those two angles is x plus x. That is to say, the value of the exterior angle PMQ of triangle QMR is equal to 2x. So in triangle PQM, we have two angles that are equal to each other, and we have the rule that in front of equal angles in the triangle are equal sides. Those two angles that are equal to each other are located between, in front of sides PQ and PM. Therefore, PQ equals to PM. PQ equals to PM. Then I draw perpendicular to QM. We define this point as L, and then I extended the perpendicular until it touches SN, until it touches QS at point N. Then we focus on those two triangles, triangle PQL and triangle PLN. In those two triangles, angle PQL equals to angle PML equals to 2x. Those two angles are equal to each other, they are both equal to 90 degrees. Angle PLQ equals to angle PLM equals to 90 degrees. Those two angles are equal to each other, they are both equal to 90 degrees. And angle QPN equals to angle PM according to further angle theorem. Those two angles are equal to each other according to further angle theorem. What is further angle theorem? Further angle theorem states that if two angles in one triangle can go into two angles in another triangle, then the first pair of angles must be also congruent. Why? Because it is complementary to 180 degrees. And we found that those two angles in triangle PQL can go into those two angles in triangle PLM. So we have in those two triangles two pairs of angles that can go in. Therefore, the first pair of angles must also congruent. That is to say, those two angles must be equal to each other. And if one angle is defined as theta, then the other angle must be also equal to theta. From the drawing you can see that theta plus theta equals to angle QPR. Again, theta plus theta equals to angle PQR. And alpha and beta also equals to angle QPR. Therefore, theta plus theta equals to alpha plus beta. Theta plus theta equals to alpha plus beta. Theta plus theta is 2 theta, and 2 theta equals to alpha plus beta. We already found out that alpha equals to 3 beta, so we can substitute alpha by 3 beta in this equation. We did it and we got that 2 theta equals to alpha is 3 beta plus beta. 3 beta plus beta is 4 beta. So we got that 2 theta equals to 4 beta. We divided this equation by 2 and we got that theta equals to 2 beta. So here you can write down that theta equals to 2 beta, and also here theta equals to 2 beta. Okay, then we proved that triangle PSN is congruent to triangle PMS. I drew those two triangles together in a new page, and we proved that those two triangles can congruent to each other. We proved that the green triangle, triangle PNS, can congruent to the white triangle, triangle PMS. So, but before that, here you can see from the drawing that angle theta in the red color minus angle beta equals to this angle. So angle NPS equals to angle theta that is 2 beta minus this angle that is beta. So actually 2 beta minus beta is beta. So we found out that angle NPS, this angle equals to beta. Likewise here we have angle MSN is the right angle, it's equals to 90 degrees. Angle PSN is equal to 45 degrees, and angle that equals to 90 degrees minus this angle that equals to 45 degrees will give us this angle that is actually angle MSP. So angle MSP will be equal to 90 degrees minus 45 degrees is 45 degrees. So we found out that this angle MSP equals to 45 degrees. So this way, then we proved that those two triangles can go into each other. Why they can go into each other? Because of the fact that those two angles are equal to each other. Angle NPS equals to angle SPM equals to beta. PS is the common side, it belongs to both triangles, so PS equals to PS is the common side that belongs to both triangles, and those two angles are both equal to 45 degrees, therefore they are equal to each other. Angle NSP equals to angle MSP equals to 45 degrees. So we proved that those two triangles can go into each other according to angle side angle rule. And because of the fact that those two triangles can go into each other, we will conclude that NS equals to MS. NS equals to MS according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say NS and MS, will be equal to each other. So MS equals to SN. So I drew triangle MSN in a new page, and we focus on this triangle, triangle MSN. We know that MS equals to SN. So this is triangle MNS. We know that MS equals to SN. And we know that in front of equal sides in the triangle there are equal angles. In front of those two equal sides we have those two angles, and those two angles must be equal to each other because they are located in front of equal sides. So those two angles are equal to each other. So if this angle is y, then this angle will be also equal to y. The sum of those two angles is y plus y, that is to say it equals to 2y. And the sum of those two angles, that is 2y, must be also equal to 90 degrees in order to complete the sum of the angles in triangle MSN to 180 degrees. We get that 90 degrees plus 90 degrees equals to 180 degrees. So we got that 2y equals to 90 degrees. We divided this equation by 2 and we got that angle y equals to 45 degrees. So this angle equals to 45 degrees and this angle also equals to 45 degrees. So actually angle MSN equals to 45 degrees. Angle MSN equals to 45 degrees. Here angle SMN equals to 45 degrees, and also angle MNS equals to 45 degrees. Angle MNS equals to 45 degrees, and this angle also equals to 45 degrees. Okay. Then we proved that triangle PQN can go into triangle PNM. I drew those two triangles together and we proved that those two triangles can go into each other. Actually, we proved that the green triangle, triangle PQN, can go into the white triangle, triangle PMN. So, why they can go into each other? First of all, angle PQN equals to angle PNM. Angle PQ equals to PM. PQ equals to PM. We have already found out that PQ equals to PM, and angle QPN equals to angle MPM equals to 2 beta. Those two angles are equal to each other, and PN equals to itself. It is a common side that belongs to both triangles. So we actually proved that the green triangle, triangle PQN, can go into the white triangle, triangle PNM, according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that QN equals to NM. QN equals to NM. So I drew triangle, we connected points M and Q together by a straight line. I drew triangle QMN together again in a new page. And we focus on triangle QMN. On triangle QMN, we know that QN equals to MN, but we know that this angle MQN equals to X. We built it like that angle MQN will be equal to X. So angle MQN, this angle equals to X according to our building, and we know that MN equals to QN. Those two sides are equal to each other, and according to the rule that in front of equal sides in the triangle there are equal angles, we will get that those two angles must be also equal to each other because they are located in front of the equal sides. Those two equal sides, therefore they must be also equal to each other. But we know that this angle is equal to X. Therefore this angle must be also equal to X because those two angles are equal to each other. And we have rule number 4 that states that the value of the exterior angle MNS equals to the sum of the angles that are not adjacent to it. And the only two angles that are not adjacent to this external angle are those two angles, and the sum of those two angles is x plus x, that is to say, they are equal to 2x. Therefore, according to rule number 4, the external angle MNS equals to 2x. So we found out that the external angle MNS equals to 2x according to rule number 4. According to rule number 4, the value of the external angle MNS is 2x. But we have already found out that the value of angle MNS is equal to 45 degrees. From the other side, the value of angle MNS equals to 45 degrees. From this equation, we will conclude that 45 degrees equals to 2x. We will divide this equation by 2 and we will get that x equals to 45 degrees over 2. That is to say, x equals to 22.5 degrees. So we found out in both methods that the value of angle x is equal to 22.5 degrees. Okay, thank you very much.